Before we talk about streams, let's look at the problem they try to solve. So let's say we have a list of movies and we want to count the number of movies that have more than 10 likes. So in this project, in the streams package, I'm going to add a movie class. Every movie should have a title and the number of likes. So private string title and private integer likes. Now let's initialize this using a constructor. So we generate a constructor. And first I'm going to select the title field and then the likes field. Now we have a constructor with two parameters. The first parameter is the title and the second parameter is the number of likes. I also want to generate a getter for the likes field. So we put the caret over here, Alt and Enter, and create a getter. Pretty straightforward. Now, back to our demo class, let's create a list of movies. So list of movie, we import it, call it movies, and here I'm going to use list of to initialize this list with 3 movies. So here's the first movie. We call it A and give it 10 likes. The name doesn't matter, just something easy to work with. So we have B with 15 likes and C with 20 likes. So we have a list of movies. Now we want to count the number of movies that have more than 10 likes. So we need a counter variable. Initially we set it to 0. Next we need to loop over this list. So for var movie in movies. Now here we need an if statement. If movie that get likes is greater than 10, then we're going to increment the count. So this is how we can count the number of movies with more than 10 likes. Now, this style of code is called imperative programming. Imperative programming is a programming paradigm or a style of programming. We have so many different programming paradigms like declarative, functional, object-oriented, event-driven, and so on. In a single application, we might have multiple paradigms. For example, we might implement certain features using the event-driven paradigm, but we might use the functional paradigm in other parts of our application. This code that we have over here is an example of imperative programming. In imperative programming, we have statements that specify how something should be done. For example, here we have statements that specify how we should count the number of movies that have more than 10 likes. So first, we initialize the count to 0. Then we loop over our collection of movies. We have an if statement, and finally, we increment the counter. So these statements determine how something should be done. In contrast to imperative programming, we have declarative programming where we express logic in terms of what needs to be done as opposed to how it should be done. For example, SQL is an example of a declarative language. We write a query to express what we need to get from a database, but we don't write the actual logic for pulling out data and filtering it. Now, streams were introduced in Java to allow us process a collection of objects in a declarative or, more accurately, functional way. Functional programming is a special type of declarative programming, but it brings some additional concepts. Let me show you an example. So if you want to rewrite this code in a functional style, we would write it like this. We start from our movies collection. Now, every collection in Java has a method called stream, and this returns a stream of objects. Now, what is a stream? Well, a stream is a sequence of objects, but it's not like a collection. It doesn't store data. It's just a way to get data out of a collection. As a metaphor, think of a water tank. The actual water is inside the tank, but we have a bunch of pipes to get the water out of the tank. So a collection is like a water tank. That is where we store some data. A stream is like a pipe. Now we can attach one pipe after another. We can build a pipeline to transform data and get it out of a collection. You're going to see it throughout this section. So over here, let's get a stream or a pipe from this collection. Now, this stream object has a bunch of useful methods. One of them is filter. With this, we can filter data. Now look at the parameter of this method. Here we should pass a predicate of movie. We talked about predicates in the last section. A predicate is a function that takes an object and returns a Boolean. So with this predicate, we can check to see if this object satisfies some criteria. Now, what is the criteria we're looking for here? We're looking for movies with more than 10 likes. So let's pass a predicate here. Movie goes to movie that get likes greater than This function is going to be applied to every movie in our collection, and only movies that satisfy this criteria will be pulled out of our collection. Okay? Now, we have another method that we can chain here called count. And with this, we can count the number of movies or objects that come out of this pipe, come out of this stream. So we get the result and store it in, let's say, count 2. What we have here is an example of declarative, or more accurately, functional programming. Because we have a bunch of functions like filter and count, we're composing these to express a complex logic. Now, as you can see in this example, we don't have instructions that specify how something should be done. We're purely expressing what needs to be done. We're saying we want to filter based on this condition, and we want to count. We don't have statements like setting the counter to 0 and then incrementing it. So this is the difference between imperative and declarative programming. So with streams, we can process a collection of objects in a functional way, and this makes our code cleaner and easier to read. I'm going to show you several examples throughout this section. Next, we're going to talk about different ways to create a stream.